This is a GCSE chemistry required practical, making copper sulfate crystals. It's also in the Key Stage 3 topic, chemical structures. I've got some sulfuric acid, 1 molar sulfuric acid. I've got some copper oxide powder, and I'm going to mix some of that sulfuric acid, about 1/3 of a tube, boiling tube, with quite a lot of copper oxide powder, okay? And we say that we're using excess copper oxide. And what that means is we're basically putting in more copper oxide than we need. And the point of that is to do with limiting reactants, okay? We want to make sure that all of the acid reacts with the copper oxide. So we put in too much copper oxide, and then later on we're going to remove the copper oxide that has not reacted, okay? We say we're putting in excess copper oxide. Now, copper oxide is insoluble. It doesn't dissolve in the sulfuric acid. It's going to be reacting in there, in that sulfuric acid, but it's not actually going to dissolve. So any of that excess copper oxide that doesn't react, we can remove using filter paper. Now, on the Bunsen here, on top of the tripod and the gauze, I've got some hot water, and what that does is it helps the sulfuric acid and the copper oxide to react. So I'm going to leave that there for probably about 10 minutes and let the copper oxide react with the sulfuric acid. I'll have some unreacted copper oxide in there because I've added excess, and I will have a solution of copper sulfate. We'll come back to that in a minute. 10 minutes. Okay, fast forward 10 minutes. I've just turned my Bunsen off. You can see I've got this lovely turquoise copper sulfate solution. When I was talking about limiting reactants earlier, because we have added excess copper oxide, it has made the sulfuric acid in this reaction the limiting reactant. A reaction stops when one of the reactants has been used up, and in this case all of the sulfuric acid has now reacted, so the reaction has stopped. I know that because I've left it for a long time, and it's the unreacted copper oxide that's left, and we're going to remove that now, okay? So we made sulfuric acid the limiting reactant, okay? And we did that so that we can get pure copper sulfate crystals. We don't want any of the sulfuric acid still having not reacted in our solution of copper sulfate. We just want it to be copper sulfate solution. So I've set up my funnel here with my evaporating dish underneath, and I'm going to, that's basically just so I don't have to hold it. I'm going to take my filter paper, fold it twice, and then pull it out from, there's now 4 parts, I'm going to pull it out from 1 and 3 to make this nice funnel. So that fits nicely inside my funnel there. And then using my test tube holders, I take my solution, I'm just going to hold that like that, and just gently pour that. I'm not bothered about this bit of unreacted copper oxide. I'll just put that back, and then I'm going to leave that there, let all of the copper sulfate solution filter through that filter paper. It's a salt, but it's soluble, so it's dissolved in the liquid, and therefore it can go through the filter paper, and that excess copper oxide that was insoluble is being trapped by the filter paper. That gives me now a pure copper sulfate solution in that evaporating dish, and then I could do one of 2 things. I could heat it over a beaker of hot water, which would just gently heat it. The danger of heating it just straight away with a Bunsen flame is it's probably going to burn, but I'm also going to be stripping it of all the water. I'm going to end up making anhydrous copper sulfate, which is a white powder, and I just want to get some nice copper sulfate crystals. So I'm going to leave that overnight, and hopefully we'll have some crystals to see tomorrow. Okay, let's just go a bit closer so we can see that solution. So you can see there is the trapped copper oxide in the filter paper, and there is my pure copper sulfate solution. Just thought I'd use this opportunity to show you how I could heat it to speed up the process to get those crystals quicker. And this is called a bain-marie. Okay, it's basically using a beaker of hot water, kind of in the way you would melt chocolate at home if you were doing some cooking. And this can just gently heat the copper sulfate solution to get those copper sulfate crystals. The water's going to evaporate from here. So I just thought I could show you this because it's really useful for the required practical to know how you can get those copper sulfate crystals. We could just wait and get them just with a bit of patience, but this is quite a good way of getting those crystals. For the required practical element of this at GCSE, you would need to write a method, probably a 6-mark question, a method explaining the stages that you would go through to get from your sulfuric acid and your copper oxide to getting your pure copper sulfate crystals. Okay, and they're going to be pure if you've made the sulfuric acid the limiting reactant. If you've used excess copper oxide, that's how you're going to get a pure sample. Okay, so think about what you're doing, why you're doing it, when you're explaining your 6 stages to get your 6 marks of making this copper sulfate. We'll have a look at that when we've got some crystals. See you shortly. Okay, here we've got our copper sulfate crystals. It really does show that good things come to those that wait, because the crystals on the left were achieved by evaporating the water using the beaker of water underneath, and the crystals on the right, which look much more impressive, have been achieved by just allowing that water to evaporate at room temperature. Much bigger crystals, much more impressive. Let's summarise what we've covered then. So we've got a reaction of a metal oxide with an acid making a salt and water, and this is always a soluble salt. And the example that we had copper oxide, we had sulfuric acid, we made copper sulfate, and first of all we made it as a solution because we had that water, and then we evaporated the water to get the copper sulfate crystals. We've also got a balanced symbol equation there. It didn't actually need balancing, so it already was balanced, which is handy. And we added excess copper oxide to the sulfuric acid to ensure all of the acid was used up. We heated to help the reactants react. We filtered to remove any of the unreacted copper oxide because it was insoluble, so it gets trapped by the filter paper, whereas the copper sulfate solution went through the filter paper because it was soluble. And then we evaporated the water to leave copper sulfate crystals. Hope you found that useful. Thank you.